Hi there. So we are back again for the circuit analysis one course. Okay, here at Kasetsart University, Bangkok, Thailand. And these topics will be on sinusoidal steady state analysis or AC circuit state at steady state. We're going to analyze AC circuit at steady state. Okay. Before you watch this topic, okay, this clip here, I really recommend that you go and watch topics 23, 24, and 25. Right, which is 23 is the review with the sinusoidal, what it is. Okay, topic 24 is phasors, how we convert from the time domain to a frequency domain. And the topic 25 is on impedance. And by now you will enjoy analyze the circuit more if you actually remembers the formulas, the tiny formulas about the impedance. So, but I will review again the formula that you need to know and what the basic transformation or conversion that you need to know to do the AC steady state analysis. Okay, so I'm going to review. Before I start, I will review what you need to know, right, before we go on. So V of t. So first, how to convert the time domain into phasor form, okay, to frequency domain. So you have your functions, either voltage or current, in the form of Vm cos omega t plus phi volt, okay, and you want to change this into phasor form. So it would be phasor V equal to Vm, right? Take the amplitude and simply the phase angle. So angle phi volt. So this is the phasor form of this function. Okay. And another thing that you need to know by heart is the impedance. The impedance, okay, denoted as Z or Z, okay. And the definition is phasor V over phasor I. Okay, and unit is ohms. The unit is ohms. Okay. And the impedance of a resistor is simply the value of the resistor itself, R, angle 0 ohms. Okay. The impedance for an inductor is J omega L, right? Well, all this formula was proven how we get this formula in the impedance in the last topic number 25. Okay. Oh, okay, so ZL is equal to J omega L. This is in rectangular form. If you want to write it in a phasor form, it's omega L, right? And the angle J is 90 degrees ohms. For the impedance for a capacitor is minus J over omega C, or in polar form 1 over omega C, angle is minus 90 degrees ohms. Okay, so you need to know this. Okay, so let's start with, I'm going to do an example for each of the method or theorem that we have done before to analyze a circuit. So let's start with the first example. Okay. First example, and this would be a review for current dividers and a basic, Ohm's law. 5 cos 3t volt. This is your voltage source. 1 ohms, 3 ohms, 1 Henry (1/9 Farad), and we want to find current I. Okay, so find I of t at steady state. Steady state means that you have the circuit is connected like this for a long time. Okay, when it reaches, it's stable, when it reaches at steady state. Okay, so please remember, whenever you hear the word like at steady state, to analyze this, you simply change all the sources into Phasor form, all the elements, resistor, capacitor, and inductor, into ohms unit. In other words, convert into impedance. So first I'm going to, of course, change 5 cos 3t into Phasor form. So 5 cos 3t into Phasor form, it's simply 5 angle 0 degrees. Okay, then I need to transform all the elements into impedance. Of course, resistor stayed as it is because it's already in a ohms, sort of, you can think of it as it's in a ohms unit already, so you don't need to convert it anymore. Okay, so therefore R stay as 1 ohm, 3 ohm stay as 1 ohm, but 1 Henry and Farad you need to change to impedance. So we're going to change 1 Henry into the impedance. So this is where, you know, your memory have to kick in, that the impedance for an inductor, right, ZL is J omega L. Omega, where's omega? Where do you get omega? You have to remember the form that this is like Vm cos omega t, right? So therefore omega, if you compare these two functions, omega is simply 3 radian per second. So it's become J times 3 times L, which is 1 Henry. So it's 3J ohms, or 3 angle 90 degrees ohms. Okay, then ZC, the impedance for this capacitor, right? The formula is, again, if you remember the formula, you know you enjoy doing these problems. It's minus J over omega C. So it's minus J over 3 times 1/9 Farad. Okay, 31339. Okay, so therefore minus 3J ohms, or equal to 3 minus 90 degrees ohms. Well, you want to find I of t, right? So let me just to make the circuit up to date. So this become your Phasor, right, equal to 5 0 degrees. This is 1 ohms, 3 ohms, 3J ohms, and this minus 3J ohms, and you want to find this current, okay, in Phasor form. So now your circuit is ready for you to analyze. Well, of course, you can use mesh, you can use node, whatever you think you're comfortable with, as long as you get the right answer for me. Okay, but for me, I'm going to choose a simpler way by simply, well, I'm going to look at this circuit was complete, right? Okay, so the current would come out from the source. So current come out from the positive side of the terminal, the voltage source, right? Let's call it I1. Okay, I1. Well, I1 travels. See, I always remind my students that when you analyze your circuit, you have to understand the circuit a little bit by imagine that you are current. You yourself is a current and you're flowing throughout the circuit. Where do you flow, you know? So now I1, right? I1 flows pass through 1 ohms, right? it reached to these junctions right here, and of course it will split right into I here, right, and split into this branch, so like two ways. So I'm going to call this I2 then, okay, right? So my thought is, okay, so if I is divided out or split out of I1, then that means I can use current divider, right? My formula would be to find I, right? I would be, if I use current divider, right, it was like Z total over ZX multiplied by IS, right? This is the formula for current divider. Okay, so that means my Z total, well, IS, of course, I don't know yet, right? Oh, in this case not IS, it's I1, right? So in this, so if I'm gonna do this, substitute the problem into this formula, my Z total would be, well, of course my IS would be I1, right, because I divided out from this I1 right here, okay. ZX would be, well, the current I passed through just minus 3J, so this is minus 3J, okay, right. And Z total, what is Z total? Z total would be the total impedance that IS give to, right, that IS give to. So therefore I1 gives to, so I1 goes through here and it divided into this, giving itself into this 3 ohms, 3J ohm in this branch, and then minus 3J ohms in this branch. But this 3 ohms and 3J ohm is connected in series, so it's 3 plus 3J, right, and it's parallel to minus 3J. So this would be the way to get my answer. But I'm missing I1. So I'm going to find I1 first. Well, I1 is simply like I total, right, coming out from the source, the voltage source, and provided for all the impedance in the circuit. So I have to find the total impedance of the circuit. So the total impedance would be, right, looking into from this purple arrow, and you sort of like condense it from the further side, away from you, and then move inwards until you get to where you're looking at. So therefore you see that the minus 3J here, okay, is parallel to 3 plus 3J, right, and the whole thing is in series with 1 ohms. So therefore you do your math, so minus 3J multiplied by 3 plus 3J divided by minus 3J plus 3 plus 3J, right, and then plus 1. So this is your Z total. So when you use your calculator, use your math skill, it turns out that your Z total will become 4 minus 3J ohm. So please, I suggest to you that when you finish watching this, you need to take your own time to actually do this by yourself again. Copy the circuit onto a blank piece of paper and do it. Having a calculator next to you, actually, press your calculator and get the answer by yourself. Don't just like, read, okay, you get this, because when you're in exam, and if you don't know how to use your calculator properly, you get it wrong, okay, and it's a pity that you got it wrong because you don't know how to use your calculator, okay, properly. Okay, so therefore we got your Z total. So I1 is, okay, Vs, so which is 50 degrees volt divided by Z total, so 4 minus 3J, okay, right. So you use a calculator, the current technology, even the basic scientific calculator, okay, you can actually type in 5 angle 0 degrees divided by bracket 4 minus 3J, and it gives you the answer, okay. But if you don't know, you have to convert this, because we're doing divisions, you have to convert the rectangular form into polar form, so it becomes 5 minus 36.9 degrees. So the answer is 1 angle 36.9 degrees M. So this is your I1. So therefore, your current I from this here, right, from this formula right here, okay. And of course, if you remember, the shortcut formula that I have been talking about is when your current, right, divided into only two branches, like in this case, this branch and this branch, so only two branches, okay, you can try to sort of like mentally remember the shortcut formula. So if I want this current I passing through this minus 3J, I take the other branch, the impedance for the other branch in, put it up, so it'll be 3 plus 3J divided by the sum of the elements in the two branches and how they're connected. So it becomes 3 plus 3J is the sum, no? So plus minus 3J and then multiply by I1, which is 36.9 degrees. And using your calculator, you get your current I to be root 2 angle 81.9 degrees amps. And this is in phasor domain. The question asks it in time domain. So convert this back into time domain. Is simply, well, this is the magnitude, right, the amplitude, so root 2 cos, omega doesn't change, okay, so it's 3t, and the phase angle is plus 81.9 degrees amps. So this is your answer. This is your answer, okay. Okay. So those who sort of understand the theorem from, before the midterm, this is like a review for you. So instead of having just resistors, now we have impedance. That's all. The rest is the same. So the next example I'm going to do is for nodal analysis. Okay, nodal analysis. Nodal analysis. So in this case, we have a voltage source 40 volt. We have 10 ohms. We have 0.1 farad, 1 Henry, 0.5 Henry, and 2 IX. And IX is right here. IX is a current passing through this capacitor, 0.1 farad. The question is, find Ix of t at steady state. Okay, so copy that. So let's begin. So the rules are change the time domain into frequency domain, change everything, all the elements into impedance. Okay, so therefore 20 cos 40 change into phasor domain is 20 0 degrees. Okay. Well, omega in this case is 4 radian per second. Right, so change 1 Henry into impedance. So equal to impedance J omega L. So it's J, omega is 4, L is 1, so 4J ohms or 490 degrees ohms. 0.5 Henry. So Z equal to J omega L. So J times 4 times 0.5, so equal to 2J or 290 degrees ohms. 0.1 farad. 0.1 farad. So impedance of a capacitor is minus J over omega C. So therefore minus J over omega is 4, C is 0.1. So the answer is minus J 2.5 or 2.5 angle minus 90 degrees ohms. So I'm going to redraw this, okay, in the frequency domain. Right, so this become 20, 0 degrees volt. This stay 10 ohms. This become minus J 2.5 ohms. This is Ix Phasor form. This is 4J ohms. Current source dependent. What's it now? This is a current control, current source, and 2J ohms. And we want to find Ix, right? So we want to find at this point Ix. Nodal analysis. So the method was, right, how many nodes are there? So there's this node right here, this node right here, this node right here, right? So I'm going to call this V1, this is V2, okay, and this is V0, right? Okay, of course another node is here, reference node is ground right there. Okay, then we have to assign the current for your, so that you don't mess up with the sign, right? So how would you, choose your current to flow out of the nodes? So current, you are the current in this circuit, come out from the source. The simplest way, go like this, current like this. If current go this direction, right, the voltage drop across 10 ohm is in the polarity is plus minus like this. Current go into the positive of the voltage drop, leaves on the negative of the voltage drops. The current Ix already assigned. Then I think, okay, I'm thinking that I'm a current, I'm coming out from the 20 volt, come here, split to Ix, then it goes here, right? So plus minus drops here. Then, well, this is already assigned, coming up here, I can't do anything about it. Then I'm going out like this, right? So this is plus minus, okay, right? So you have to understand also that, well, V2 is a voltage drop across the 2J ohms, also a voltage drop across this current control current source. Okay. Now, the steps to do nodal analysis is that you write KCL, right, for your unknown node voltage. V0 you know, right? This one you know, the node voltage, which is simply 20, 0 degrees volt. Okay, the ones you don't know are V1 and V2. So we're going to write KCL at V1. Right, Kirchhoff current law. Okay, so it is, well, I'm going to change it right away into the node voltage form. Okay, so it's this current going in, right? This circuit going in, right? So the current is the voltage drop across the 10 ohms divided by the 10 ohms. The voltage drop across this 10 ohm is the potential difference between this point, the positive terminal at this point here, subtract minus the potential on the negative terminals right here, so this side. So therefore, the voltage drop across the 10 ohm is V out, right, which is, we say that it's 20, 0 degrees minus V1 over 10, okay. Then this is current coming out from this node, so minus Ix, right? But Ix is simply V1 over minus 2.5J. Then this current are leaving V1, so minus the voltage drop across, this is the current passing through 4J. And the current passing through J, right, is simply the voltage drop across 4J divided by 4J. Right? I equal to V over Z. So the voltage drop across 4J is the potential difference between the positive terminal here V1, right? Subtract the one in this minus terminal, which is V2. So it's V1 minus V2 over 4J equal to 0. So therefore you have 20 0 degrees over 10 minus V1 over 10 equal to V1 over minus 2.5J minus V1 minus V2 over 4J over 4J. And if you do the math, right, then you would have, in this case, 1 plus J 1.5 V1 plus J 2.5 V2 equal to 20. This is equation number 1. Okay, so you need to really, take your time and do the math. Otherwise, you can't do it in the exam. You get lazy, and you don't know how to go about it. Next one, KCL at V2. KCL at V2. Okay, so V2 is right here. What do we have? We have this current going in, right, from the source, dependent source. So we have 2Ix, right, 2Ix. And then this current going in also. So it's plus V1 minus V2 over 4J. Okay. And minus this current is leaving, right? This current is leaving. This current is the current passing through the 2J. Right? So therefore, it's simply V2 over 2J equal to 0. But Ix, we know that Ix is simply V1 over minus 2.5J. So therefore, substitute it back. So it becomes 2 V1 over minus 2.5J, right, plus V1 minus V2 over 4J, right, equal to V2 over 2J. And if you do the math, you will get 11 V1 plus 15 V2 equal to 0. So this is equation number 2. So therefore you have these two equations to solve for V1 and V2. Actually, we want to find Ix. To find Ix is equal to V1 over minus 2.5J. You need to find only V1. You don't need to find V2 even. Okay. So to do this, I set it up in the Kramer's rule in the matrix form. So I would have 1 plus J 1.5, the coefficients, metric coefficients, 11, 15, times V1, V2 equal to 20 and 0. So to find V1, right? So V1 is the determinant of the matrix when you replace these coefficients to the first column. So 20, 0, 2.5J, 15, divided by the determinant of the matrix, the coefficients itself. So 1 plus J 1.5, J 2.5, 11, and 15. And you do that and you get 300 over 15 minus 5J. And the answer is 18.97, angle 18.43 degrees volt. So this is your V1. So therefore, your Ix, the formula is V1 over minus 2.5J. So it's 18.97, angle 18.43 degrees divided by 2.5 angle minus 90 degrees. So the answer is 7.59 angle 108.4 degrees amps. So you get your value for Ix in phasor form, but you need to answer it in terms of time domain. So convert that back. You simply reverse it to become 7.59 as the amplitude. Cos omega was 4 in this problem, 4t, and the phase angle 108.4 degrees amps. So that's nodal analysis, review of nodal analysis. Okay. Next one I'm going to do is mesh analysis. Okay, mesh analysis. So I hope what I did now sort of kick your memories back. Oh yeah, right, this is nodal analysis. Okay. Then mesh analysis is the next example to show how we do mesh analysis. Okay. So in this case, in this example, I have already converted into the frequency domain. Minus 2j ohms, 4 ohms, this is 10j ohms, 8 ohms, another minus 2j ohms, and then a voltage source, independent, 20, 90 degrees volt, and we want to find I out right here. What's I out? What's I out? Using mesh analysis. Right, so let's do it. So finish copying. Right, so we define the steps that I have taught you in I think it's in topic like 7, it's like 6 or 7 or 8, you know. Okay, so is that you assigned, right, mesh currents clockwise directions. So let's do it. So clockwise directions for each one, I1, I2, and I3. Okay. Well, you want to find I out, so look at it. Oh, I out is nothing but I2, right? But it's in the reverse direction because I2 flow like this, I2 go like this, right? In the opposite direction. So actually you have to find I2 in this problem. I out is equal to minus I2. Minus I2. Okay. What else? What else can you make maybe this circuit simpler? Well, look here, I3 is here. I3, if you assign I3 in this mesh, I3 flow like this, right? Out like this, up to here. And actually like this. In this branch is I3. Only, okay? In this, across the current across this minus 2J, of course, consists of I3 and I2 because it's shared between I3 and I2, right? The current passing through 10J consists of the combination of I1 and I3. So only I3 is right here where I drew. And look at this. This is a current source. This current source gives out 5 5 amps. So therefore you can automatically say that, oh, say my I3 is nothing but 50 degrees amps. So the only KVL that I have to write is I1 and I2. So let's do it. So KVL I1, right? Well, when I write down the formula of KVL for mesh I1, I take my I1 as my main current. So I1 flows into the positive of voltage drop of all the elements. So plus minus like this, right? I1 go through 10J ohm this way, go through minus 2J this way, right? And 8 ohm this way, so plus, going to the plus. So therefore, well, I'm going to start it from right here, right? So it 8 I1, right? So we drop across 8 ohm is R times I, so 8 I1, okay? The voltage drop across the 10J is I1, right? Is 10J multiplied by the current going through it. So positive 10J, well, I1 goes into the positive side and the purple, in the purple sign, purple color sign. I3 enters in the negative side, so minus I3. Okay. Plus the voltage drop across minus 2J, right? So it's minus 2J multiplied by the current. So current I1 enter the positive, so I1, right? Current I2 enter the negative side of the purple negative sign, so minus I2 equal to 0. Okay, so it becomes, right, you factor I1, well, I3, we know that it's 5, so this is 5, right? This is 5 amps. So therefore, when we factor and group I1 and I2 together, you have 8 plus 10J minus 2J I1 plus, oh sorry, I haven't, okay, 2J I2, okay, minus 10J I3. Well, I3 is 5, so equal to 0. So therefore you get, right, 8 plus 8J I1 plus 2J I2 equal to 50J. This is your equation number 1. Okay, then KVL I2, right? So therefore now KVL I2, taking I2 as my main mesh current. So I2, right, pass through minus 2J in this direction. So, right, go like this. So positive, negative here, right? And then into like this, so positive, negative. Right, so I'm going to start from at the bottom right here. So KVL I2, the voltage drop across this minus 2J ohm is, right, minus 2J multiplied by I2, right, it enters the positive side of this pink sign, but I1 goes into the negative side, so minus I1 plus another minus 2J, right, but this one is shared between I2 and I3, so it's I2 minus I3, okay, and then plus 4 I2, right, and then plus 20, 90 degrees equal to 0. So group them together, I would have 2J I1 plus 4 minus 2J minus 2J I2 plus 2J I3 equal to minus 20, 90 degrees. Okay, and so I will get 2J I1 plus 4 minus 4J I2, right? And if this is 5 times 2 is 10, go in the other side, it becomes minus 30j, right? This is j also, so minus 30j. So therefore, this is your equations number 2. Okay, so I'm going to set it up. So now I want to find I2. I'm going to use Kramer's rules. So write it in the form of matrix. So you have 8 plus hj. This is 2j, 2j, 4 minus 4j times I1 and I2 equal to 50j and minus 30j. So this is in a matrix form, and you solve for I2. So therefore I2 is equal to the determinant of 8 plus 8j, 2j, and 50j minus 30j divided by the determinant of the matrix itself, 8 plus 8j divided by 2j, 2j, 4 minus 4j. Okay, so you find the determinant of these two matrices divided together, and the answer you will get is 6.12 angle minus 35.22 degrees amps. But the answer I out is equal to minus I2. So therefore it is minus 6.12 angle minus 35.22 degrees amps. Okay. Or if you don't like the negative sign in front of minus 6.12, you can write it as 6.12. The angle is minus 35.22 plus 180 degrees amps. Okay, so that's an example for mesh analysis. Okay. Next one is source transformation. Okay. Next example is on source transformation. So source transformation is a theorem that you can transform voltage source into current source and current source into a voltage source. So whenever you can see is part of the circuit, okay, and it has an impedance connected in series to this voltage source, okay, you can transform this into a current source, okay, and the value of the impedance stay the same, but the locations, it becomes connected in parallel to the current source, and the value of the current source becomes Vs over Zs, just like sort of like Ohm's law, I equal to V over R, so it's V over Z. Okay, and if you have a current source, if you see a current source with an impedance parallel to it, connected in parallel to that current source, you can transform this portion into a voltage source by relocate your Zs to become in series with that voltage source that you're going to transform to, and the value of the voltage source become Is times Zs. So this is source transformation, okay, in case of the AC or impedance. Okay, so an example to this, example, if this is 20 minus 90 degrees volt. Find Vx. So the problem is find Vx. Okay. Find Vx using source transformation and other, like Ohm's law or dividers or something. But, start with a source transformation. Okay, let's do it. So if you need to use a source transformation, you have to recognize that, okay, there's a voltage source here, right? Connected in series with the 5 ohms. So I'm going to transform this into a current source. So transform this into current source, right? So 5 ohms stay the same values but change positions, right? And the IS, of course, become 20 minus 90 degrees divided by 5, right? V over Z. So it become 4 angle minus 90 degrees amps. Okay, the rest of the circuit, right, you stay as is. Like this. So you get this circuit. Then of course you see that we have to look and recognize that, oh, this 5 ohms, right? And this branch here and these branches are in parallel to each other. And this 3 ohm and 4J are in series, right? So I can sort of like combine this together, right? So this is 5 parallel with 3 plus 4J. Okay, so let's call it Z1. So I recombine this and call it Z1. So Z1 is equal to 5 times 3 plus 4J divided by 5 plus 3 plus 4J. And the answer using the calculator, you will get it's equal to 2.5 plus J 1.25 ohms, or equal to 2.795 angle 26.57 ohms. So when I draw this, I would have it, my circuit becomes 4 minus 90 degrees amps, and this is my Z1 equal to 2.5 plus J 1.25, and this is 4 ohms minus 13J ohms, and this is 10 ohms, and Vx is still the same. We haven't touched, that portion of the circuit at all. I want to find Vx, no? Somehow if I can get this all in series, I can use voltage divider. So why don't I transform again, right? I have a current here, right, in parallel with this Z1. So I'm going to change it, transform this into a voltage source again. So, right, so Z1 stays Z1, but change positions. So this is 2.5 plus J 1.25 ohms, right? And this become 4 minus 90 degrees times Z1, okay, and it becomes 5 minus J 10 volt. Okay, Z1 is here. Okay, and the rest of the circuit stay intact. So 4 ohms minus 13J ohms, 10 ohms minus Vx. So there you have transformed that circuit into simply one big loop, right? So just that one loop. Okay, so I think life is much easier now because you want to find Vx. So looking at here, Vx divided out from this voltage source here. Okay, so therefore you can use voltage divider. So therefore Vx, I hope you know what to write for voltage divider, what Vx equal to, right? Vx, right, is of course Zx over Z total times Vs, the general formula. So therefore if you apply it to this circuit, it will be 10 over Z total, which is right, so 2.5 plus J 1.25 plus 4 plus minus 13J plus 10, right, and your Vs is 5 minus 10J. Use your calculator, please. Use your calculator. Your answer should turn out to be 5.519 angle minus 28 degrees volt. Okay, whatever form you want to answer is fine with me. Okay, but it's in a Phasor form. So this is an example for source transformation, how you work with source transformation. Okay, so next one I'm going to do superposition. Example for superpositions. Superposition theorem. Right, okay. This is an example I got from a textbook of Alexander. I think it's a very good example. It covers everything. Okay. Okay. Right, just to remind you, superposition theorem is when you have a circuit with more than one sources. Okay, and the way to apply this superposition is that you activate one source only, and you turn off the other sources. So therefore if the other source is a voltage source, you short it. If it's a current source, you open it. Then you solve your problem with that particular source that you activate only. Okay, keep it, when you get the answer, keep it first. Then you do the same thing with the other source that you turn off before. So you take the second source, do the same thing, open other current source, short other voltage source, right? Get the answer for the second source acting alone, and then at the end you add all the answer up to get the final answer. So this is superposition theorem. Ring a bell? Does it ring you any bell? Okay. Well, for the AC circuit, this superposition is particularly important for one type of circuit, and that is whenever you have a circuit with sources that have different omega, different frequency. Okay, then you have to use superposition. Okay, Okay, so for example, this is a very good example of a superposition of a circuit with different frequency. Okay, so this is 10, this is the voltage source with 10 cos 2t volt. Okay, and this is 2 Henry, this is 2 sine 5t amps, this is 1 ohms, this is 0.1 farad, 4 ohms, and this is actually a DC source, 5 volt. Okay, and the question is, please find V out. So find V out at steady state. Okay. So you realize that, see, voltage source has omega equal to 2 radian per second. The current source has omega equal to 5 radian per second. DC value doesn't even have omega, right? So when you sort of like, if you somehow forget what I just said, and you come to a problem that, hey, how come this, I have 2 omega, if this j omega, I have to find impedance for j omega L. Which omega do I use? 2 or 5? Whenever you have that doubt into your mind, okay, you have to think that, oh, okay, that means I have to do it separately. At one time, omega equal to 2, another time at omega equal to 5. And hopefully it will ring a bell to you that, oh, I have to use superposition. Okay, so I'm going to now start analyze it using superpositions. So first I'm going to activate the DC first. So I'm going to keep the 5 volt, right? And of course, I have to short and open. So I sort of, what is it now? Short the 10 cos 2t and open 2 sine 5t. Okay, so therefore if I just do that first, so short, open, current source, 1 ohms, capacitor, 4 ohms, plus minus 5 volt, and you want to find V out right here. So let's see. Well, if you go on with the impedance and you say, okay, I have to find the impedance, right? Well, this is, I would say omega is equal to 0. It's a DC. So that means that L is j omega L, right? So my impedance is 0, right? Omega is 0 ohms. Oh, I have no impedance. No impedance at all, right? That means that if you have no impedance, it would act like simply a wire. So it would be just like a short. Whereas ZC is equal to minus j over omega c. If omega is equal to 0, this is infinite. Ooh, my impedance will have very high, it would go against the current, very, high values. So it won't let current going through. Oh, that means my capacitor would act like an open circuit. Okay. So this actually falls into, if you remember the rules for capacitor and inductor in DC circuit, is that if your capacitor, is being charged for a very long time at steady state, right? Your capacitor would act like an open circuit. And your inductor would act like a short circuit under DC steady state. Okay, same thing. So now what's V out, right? So let's look at first, if I'm a current, what does this, the current in this circuit do? So current come out from 5 volt, go like this, continue, go, Oh, one loop. So there's a current I going like this. Okay. If a current I going like this through this, right, there will be a voltage drop like this, voltage drop like this, right? So therefore, according to, if I write this as V1, right, voltage drop across 1 ohms, okay? So that means V1 ohms is equal to V equal to IR. So V equal to IR, right? So I times 1. What's I? My current I is simply 5 volt divided by 4 plus 1, right? Which is 5 over 5 equal to 1 amps. So therefore V1 is equal to 1 volt. But the answer I want is V out prime. V out prime here, which is the opposite direction as the opposite polarity as V1. So therefore my V out is equal to minus V1 equal to minus 1 volt. So first answer, right? So V out is equal to minus 1 based on the 5 volt source alone. Second, okay, step, I'm going to keep the 10 cos 2t. So I will open the 2 sign and short the 5 volt. Okay, so therefore the picture would look like this, right? There's a voltage source here. Open that current source, right? 4 ohms and short the 5 volt. And you want to find plus minus V out double prime. Okay. Well, I'm going to change also because we have to analyze under steady state. The rule is that you change the time domain into phasor. So this become 10 0 degrees. So this is 10 0 degree volt, right? L is 2 Henry, right? Change it to impedance. So ZL is J omega L. Omega in this case is 2 and L is 2 Henry. So it become 4J ohms. ZC equal to minus J over omega C. So it's equal to minus J over omega is 2. And the capacitor value was 0.1 farad. So the answer is minus 5J ohms. So this is 4J ohms and this is minus 5J ohms. So this is a circuit you have to analyze. So let's see, how would I do that? Well, V out double prime is here that I want to find. If I can see that this 4 ohm is parallel to minus 5J. If I condense them, combine them together, it still doesn't affect my V out double prime, right? So I'll do that. So this would be my impedance, which is 4 parallel with minus 5J ohms. 1 ohms, 4J, 10 0 degree volt, plus minus V out double prime. See? You should be able to see it and smile that I can get the answer now. It's only 1 loop, no? And I want to find the voltage V out double prime. 1 loop, it means that V out double prime divided out from the 10 volt. I can use voltage divider. But before, what is Z1? What is this Z? Okay, Z1. So 4 times minus 5J over 4 minus 5J. And the answer is 3.1 angle minus 38.7 degrees ohms. If you want to transform it into, write it in rectangular form, you can do that too. Use your calculator to change it. So that's that one. So therefore, using voltage dividers, it becomes 1 ohms divided by 4J plus 1 plus 2.42 minus 1.94 J times 10 0 degrees volt. And the answer using your calculator turns out to be 2.498 angle minus 30.79 degrees, or 2.145 minus J 1.27 volt. Okay. So you want to write it in terms of time domain. It's 2.498 cos of 2t minus 30.79 degrees volt. That's your second. That's your V out due to the voltage source 10 cosine 2t. Third one, the third source. So 3 sources, you have to do it 3 times, 3 steps. Okay, we're gonna keep the 2 sine 5t. Okay, 2 sine 5t, which is, in other words, equal to 2 cos 5t minus 90 degrees. Okay, in this case, omega is equal to 5 radian per second. So if you change this current source into phasor form, it's 2 angle minus 90 degrees amps, right? And using omega equal to 5, right? Your ZL, J omega L is equal to J times 5 times L, in this case is 2 Henry, so it's equal to 10 J ohms. And for your ZC, minus J over omega C equal to minus J over 5 times 0.1 farad, turn out to be equal to minus 2 J ohms. So therefore, when we draw our circuit in this case, you short the voltage source. Oops, hold on. Short voltage source, your inductor becomes 10 J ohms, right? You keep your current source, which is 2 minus 90 degrees amps. This is your 1 ohms, and you want to find V out triple prime. And your capacitor is minus 2 J ohms. You have 4 ohms here, and you short your 5 volt DC. So this is a circuit that you have to analyze. So looking at this, my V out triple prime is here. I see that 4 ohm is parallel with minus 2J. So I'm going to combine this together first to make my circuit look a little bit easier to see. Because when I do that, my 1 ohms, my V out triple prime is not affected. So this becomes 4 parallel with minus 2J ohms. So it's 4 times minus 2J over 4 minus 2J. So turns out to be equal to 1.79 angle minus 63.44 degrees ohms, or equal to 0.8 minus J 1.6 ohms. So how can I find V out triple prime? See, I'm a current. I have to come out from the source. So current 2 amps come out, split into 2 branches. So if I find the current I out here, I times 1. If I multiply it by 1, I would get the answer. Correct? Can you see that? Hope you can see that. Okay. Well, the current split out of the two, right? I out split out from 2 amps right here. So I can use current divider. Okay, I'm use current divider. And the 2 amps here, the current source divided into 2 branches. And we have a shortcut formula for that, right? So for any current divided into 2 branches, so therefore I out is equal to I out passing through this branch 1 ohms and this impedance here. So the formula for the shortcut formula is I out then is equal to, you take the other branch, so 10J, the impedance in the other branch, divided by the sum of the elements in the 2 branches, and how they're connected. So it's 10J plus the one in this branch is 1 ohm in series with that 0.8 and J 1.6 multiplied by 2 minus 90 degrees amps. Okay. So use your calculator again. So can you see now how important is your calculator is? Okay, in these topics, your I out is equal to 2.34 angle minus 77.9 degrees. Okay, amps. So therefore, V out triple prime is 1 ohms multiplied by I out, so equal to 2.34 angle minus 77.9 degrees volt. If you change this into time domains, it's equal to 2.34 cos, what was the omega? 5t minus 77.9 degrees volt. Okay, but if you want to change it back to sine, since at the original circuit it was sine, right? So then your V out triple prime of t is equal to 2.34 sine 5t minus 77.9 plus 90 degrees. So it's equal to 2.34 sine 5t plus 12.1 degrees volt. This is V out triple prime. Okay. At the end, your answer V out of t would consist of V out prime plus V out double prime, V out triple prime here. Please answer in terms of time domain. Please do not answer in, some of you may, write in Phasor domain, right? V out prime, V out double prime, V out triple prime in Phasor domain and add them up to one value. That's wrong. You cannot add them up that easily because they are with different omegas. Okay, so therefore, write it in time domain. Leave your answer in time domain, please. So this is minus 1 plus 2.498 cos of 2t minus 30.79 plus 2.34 sine 5t plus 12.1 degrees volt. So this is the answer. And this is how you use superposition theorem when you have a circuit with different omega. Okay. I think this topic, this clip is too long now. I think you should take a break. And I will cut it right here for this session. So it would be circuit analysis, AC circuit analysis at steady state part 1. Okay, and I will continue with Thevenin and Norton on the part 2. Well, go and take a break. Thank you. Okay, see you. Okay, so 26 นี้เนาะพัก